Okay, this is part two of understanding more about projectile motion. So this time it's understanding the formula since we are done talking about the variables. So again, let's have a review. We have the velocity, we have the distance or displacement, we have the time, we have the gravity, and we have the angle theta. Okay? First, in a sample problem, it is always like you need to find the answer to how fast the object is, how far the object is, or how long did it travel. These are the only three things you need to remember in a sample problem or in the future problems that your teacher will give you. It could either be you need to find how fast it is, or you need to find how far did it travel, or you need to find how long did it travel or the duration. Now, first and foremost, to focus on velocity or the speed of the x component, again, v sub o, I will just highlight v sub o right there. V sub o is the initial velocity given by a sample problem. Let's say, for example, a rock was hit, let's say, 20 meters 20, 20 meters per second. This is your V sub O in a sample problem. Let's say, for example, like this. That's just an example. Remember that our V sub O is a combination of, again, X and Y. So we need to chunk them down into this and into this. We need to chunk them down. Okay? So that's it. So to be able to find the velocity of the object, okay, in a given problem, determine your initial velocity first. That is if initial velocity is given. If initial velocity is given, then your angle is also given. Then you won't have any problem finding your initial velocity of the x component, especially the final velocity of the x component, because even if the initial velocity is let's say 20 again meters per second, in the final velocity it will stay the same. It will remain constant. Regardless, it will remain constant. Okay. So again, take note that you're given if you are given initial velocity like this one. Okay, good thing. If you are given angle theta, it's also good thing. So it's easy for you to find your v sub ox. Okay. So angle theta, just use the calculator and substitute the values and you will find the answer. Next, finding or focusing on the velocity of the y component. So to be able to understand on how to get the velocity of the y component is, again, you need to make sure that there is a given variable of the initial velocity. And then just do the math, substitute initial velocity given in the problem and the angle theta in the problem so that you will get to chunk down the velocity. Therefore, your v sub ox and your v sub oy is different. Okay? So we can say that your v sub ox is not equal to your v sub oy. Okay? Yes. So that is it. Then we can also use the formula on how to find the final velocity. So in order to find the final velocity, if you found out your initial velocity in the y component already, and that's already okay, g is constant, negative 9.8, and especially if you have your time, then you will get your final velocity. Okay? Well, it is always given that the final velocity on top or the highest peak is 0. So in order to, use this formula, you can derive this formula to find time. I will discuss about that later about finding time. Okay. So we are done with understanding on focusing on velocity. Next, let's focus on displacement, especially in the x component. So, when you want to find the displacement of the x component from point A to point B, or how far did it travel from left to right or right to left, we will use this formula, this one. Okay. Let's say for example, in a given problem, this is missing, this is given, and this one, you were only given v sub o. It's just that you are only given this one. Therefore, you need to have the first step. So in order to get your final velocity, you need to use this formula. Okay? Also, especially when the angle is given. Okay? When the angle is given, or there is an angle given. So when the angle is given, you can find out your initial velocity x, and you will find out your v sub x, or the final velocity, and it's easier for you to get your dx. Okay? So if this is given, and if this is given, then it's easy to find your dx. Next, your y component for the displacement. Your dy is equal to the initial velocity of the y component times time plus 1 half gt squared, or to simplify it, we will just put 0.5 gt squared. 0.5 gt squared. Okay? In a full trajectory, this part right here is the other half, and this part right here is the other half. That is why in a horizontally launched projectile motion, we can therefore say, let's say for example this, okay, on top of something, okay, an object is thrown horizontally with no angle right there. This is just half, and there's an imaginary half under here. That's an imaginary. Okay, so this part right here again is v sub o y times t, and this part right here is 0.5 gt squared. Okay, and so to be able to solve that example for the horizontally launched projectile motion, your formula will be as simple as dy is equal to 0.5 gt squared, so that you can definitely find your dy. As simple as that. Or when you found out your final velocity in the y component already, in the final velocity, I mean initial velocity in the y component as well, our g is constant, then there will be no problem for you to find the dy. So there are two formulas in order to get your dy. Okay? Next, to focus on time, to be able to understand how to get the time, we just derived the formula. So we derived this formula from the displacement right here. So we derived that formula, and you can copy this formula so that whenever we have problems and the given are this one and this one, you can use this formula to solve for time. Or what if the given problem is you need to find the time, but you are given only this or this, and this is constant. So it's easy for you to find the time. Or in some cases for the half projectile, you will just find the square root of dy over 0.5 g to get the time. Okay, so let's review. Again, there are three things that the teacher wants you to answer. It could either be velocity, or how fast an object is moving. It could either be about displacement, how far an object moved, and a variable of time, how long or the duration of the object was moving from the time of flight until it went to stop. Okay? So I want you to fully understand the formulas so that you are going to be ready to answer any problems. Next technique is we will understand the formulas, and we will provide tips and tricks or make strategies on how to understand better a word problem, especially this kind of topic. Thank you so much.